Welcome, everybody, to today's symposium on the system theory of algorithms, which is sponsored by our control network, our national one, called the NCCR Automation, headed by John Ligeros over here. I still have to get used to it, but it's real nice to have a physical audience again, so I'm very happy that you all are here. I'd like to quickly introduce the topic and set sort of the tone for these talks coming up. Those of you that have been here 2 weeks ago, please forgive me that I used 3 slides from 2 weeks ago, but I promise the rest will be very brief and cut short. Just want to quickly introduce the topic, why we're here and what we're discussing today. So there's a different perspective you can take on algorithms. One is that algorithms just essentially a piece of code, possibly initialized with some random seeds or data, and that spits out an answer so that it's isolated, monolithic, and perfect in its execution. Think about something like solving a least square problem. The solution is the pseudo-inverse of a data matrix. Today, we want to take a different viewpoint and think about algorithms, especially algorithms in control, learning, optimization, and so on, as discrete-time dynamical systems that have real-time data inputs and outputs and also propagate uncertainty. So very much like a block diagram. And to come up with the same example as last week, sort of that relates to ETH Zurich, is of course Kalman filtering versus least squares. So least squares, sort of this idea of a monolithic algorithm, a perfect piece of code that spits out an answer based on an initial seed. Whereas a Kalman filter solves for the same problem, but it can deal with real-time inputs and real-time outputs, and also tells you how to propagate uncertainty, in this case, mean and variance. 2 slides on examples. And again, those of you that have been here 2 weeks ago have already seen those. When and why this particular dynamics perspective on algorithms is relevant. Of course, when you think about the Kalman filter, you want to use this as a subroutine interconnected with a physical system and a decision-making algorithm, a controller. So it's relevant whenever you interconnect systems. That's also the case when you think about machine learning pipelines, for instance. Also, when you operate these algorithms online, based on real-time streaming data inputs. And finally, whenever you're in resource-constrained environments, that is when you cannot solve a problem to perfect execution, to epsilon optimality, but you just have to, whatever, time for 3 Newton steps, and then you hit the system again. And that's, of course, very common in control. For instance, MPC encompasses all of these aspects. There's other reasons when and why one should think about algorithms as dynamic systems, namely when they become part of our daily lives and we interact with them. Let it be interacting with an autonomous driving algorithm or interacting with a recommendation system on the internet. Whenever you want to understand propagation of uncertainty, good luck understanding that from a non-system theoretic perspective for things like a particle filter. And of course, also when you have not just one single optimization objective, but a game. So you have self-interested decision makers, as in infrastructure networks or supply chains. Then you'd like to understand how they affect each other and eventually find an equilibrium or not. So that was my short summary, and forgive me for showing the same slides as 2 weeks ago. Here's another example that I dug out from just down the hill. A lot of our alumni here from Control are going into the finance world, and they use Control for the dark side, if you want so. I'm sure Sean can tell a few stories about that. But that's really a case to think about high-speed trading when you have algorithms that are interconnected in real time, that interact with another and interact with humans in the loop, and are subject to noise, uncertainty, delays, and so on. And one should really understand the feedback mechanisms between these algorithms in the system theory. And I hope these guys down the hill are doing that. Honestly, I don't think so. So here's an example from the Dow Jones 2010 called the flash crash, when they brought down the entire Dow Jones, like a huge portfolio, by 10% within a few minutes. Also attributed to algorithms. Okay, so a good example when and why one should understand feedbacks between algorithms and humans. Good. Few cliffhangers before I conclude. What are we after today in these talks and also in the subsequent panel discussion? The first one is, are algorithms just discrete time dynamical system? That is, do we have a hammer and are we looking for nails? Right? Maybe, maybe not. And if so, can systems and control bring some order, structure, new methods to problems like this, or problems like, I don't know, like that, which are more or less a little bit the Wild West, where there's not a lot of theory approaches to bring up certificates. And then finally, of course, is this a good topic where you can bridge different communities from the theory end of things, like optimization, control, maybe machine learning, statistics, but also different applications. And of course, each of this should be affiliated with a question mark. That is, do we really have a hammer and the others are nails? Can system control bring anything here, or is it just us playing with it? And, do we really bridge communities, or does anybody in the world of operations research care that we're sitting here? And that's, of course, to be answered by our speakers and not by myself. And, of course, the summary is this, is this just a short-lived hype cycle, or is this possibly a golden age for the tools that we've been developing for the past few decades? Golden age. All right, so we have our first panel question here. Very briefly in the logistics. So we had 4 excellent speakers here 2 weeks ago, and we have another 4 excellent this week. The start will be made by Christian Ebenbauer and Sean Main. They'll give 2 talks, about 40 minutes each, 5 minutes of question each. We'll have a coffee break right outside. And then we'll have Laurent Lessin and Niao He, who is, I think, still teaching her class right now, giving the other 2 talks. This will be followed by the panel, and I envision that the panel will continuously transition to wine and drinks right afterwards outside for the upper room. That being said, I'll pass on the word to Dominic and Giuseppe, who are moderating the session now.